Thank you, Cam. Thank you, Steve. I just was talking really, really quiet. That's all that was happening there. What's up, what's up, what's up? Yes, exactly. As you said, Ivan, a little bit of rust. Got to knock off that rust a little, you know, and get back into the swing of things. It's been a while, but I was saying really stupid stuff anyway, so I'm glad that I get a chance to redo it and just say what's up to everybody. And it's really good to be back on this beautiful Monday night, November 29th. It's time to take back our Monday nights. That's really what the spirit of what I was saying was. It is time to take back the Mondays. That's all I was saying, Steve, and I think that it is indeed time. So what is up, Ray? How we doing? Welcome, welcome. Welcome, everyone. Got some controls over here on this monitor, so whenever you see me look over here, that's all I'm doing is just looking to take care of those controls. But I'm very excited to be here with you guys again on this beautiful Monday night, and we're going to do some Model Monday live action here. And I decided to kind of ease into things a little bit, deviate a little bit from our standard agenda. And tonight, I think what we're going to do is we're going to do kind of a let's build type of a scenario here, in that we're going to be building this set of tongs. Now, this is going to be the first time that I'm actually personally building these. Tom Smith, Smitty from our group here, he saw this post on Reddit, and I think that it was up for maybe 5 seconds, and he had already modeled up these tongs that we see on screen here. So thank you to Tom for doing this, for modeling this up, and I just decided to poach it, and I'm going to use it for tonight's example, just as kind of a guide. But really what I'm going to be doing is modeling the actual parts here that are behind me, and we're going to use these beautiful parts that we've got here that are probably a little bit dirty and come up with our own version of these fireplace tongs. What is up to Tom Smith? Says took him 6 minutes to do that, actually. 6 minutes. Well, Tom, I'm going to be using that a lot throughout my presentation today, so thank you so much for posting that image, because it saved me having to model it, and now we're going to be able to do it live. What's up, Gerben? Our champion from the previous TooTallToby tournament series is here joining us tonight. What's up, Table 36? Old friend of the show. Great to see you in here as well. Thanks so much to everybody for tuning in. So I think what we're going to do here is we're going to go through and we're going to try to kind of imagine how we would construct this part. I threw a post up on Reddit today. I said, you know, how would you build this model? Got a lot of great responses, a lot of, you know, interesting ways of maybe coming up with this thing. But I think that what I'm going to do here, just kind of looking this thing over, having not built it yet, is I'm going to start out with the rivet. And the reason I'm going to start out with the rivet is because when I assemble this thing, I'm going to use that rivet as kind of my anchor point for the assembly. So I figure if I model that part first, so here we can see the physical device here. If I model that part first, it's going to allow me to kind of, you know, open and close this thing, kind of like what I'm showing on camera here, while holding that rivet in the origin location. So that's just kind of my plan. I don't know if I'm going to, you know, if I'm going to stick with that plan or if I'm going to change it up. We're doing this live. Saw somebody else in Reddit today say we're doing it live, and that is exactly right. We're doing it live tonight. Then I'm going to model up a washer. There's actually a washer that goes in between the top and the bottom component and in between, or kind of in line with the rivet. We're going to then make the assembly. Like I said, we're going to have that rivet act as our anchor point for the entire assembly, so I think it makes sense to make the assembly next. We're then going to model up the handle, and we'll finish up by modeling the gripper. And I don't know for sure if I can use the same parts twice, or if there's a left-hand, right-hand version, both for the handle and for the gripper. So I'll just figure it out as we go through. I think they're the same. It certainly, from a manufacturing point of view, would make sense for them to be the same, but I don't know for sure. So we're going to find that out together. But you guys know this is Model Monday Live, and so when it comes to Model Monday Live, we got to have a challenge for the chat. I know a lot of you guys out there are looking forward to tuning in tonight to kind of dust off maybe some of your skills of doing the Model Monday Challenge. So we're going to run through and do a challenge here with none other than one of those parts from this challenge that we're putting together tonight from the Fireplace Tongs. So we are going to do a challenge here. What you're going to need if you want to participate is a YouTube chat login and a 3D CAD system that can input density and output mass. If you're here for the first time, if you're a first-time viewer of the show and you want to compete, this is your chance to boot up your 3D CAD system. Maybe it's SolidWorks, maybe it's something else. I know, Gervin, you used something else, or at least you did when we did our last tournament. You know, all are welcome here. It's a very inclusive spirit when you hang out with TooTallToby on Model Monday Live, so all are welcome here. And whatever CAD system you happen to have, this is your chance to boot up that CAD system. And then what you're going to do is you're going to acknowledge the terms and conditions, the terms of service, which is this is meant to be fun and good-spirited, and I will and have made mistakes on prints. So there will be some prints where I miss a dimension. You just kind of have to go with it and try to interpret the best you can. Tom Smith in the chat says the two grips are the same and the two handles are the same. So that's good to know. We're gonna see if that is in fact true. I think it's probably true. We'll find out for sure. It's kind of interesting the way that this mechanism comes together. I'll show you a picture of it in just a moment. Tonight, our challenges are going to use one of these three materials and one of these two unit systems. So make sure you've got a template that has these. These are the default densities for these materials in SolidWorks. So if you're using a different CAD system, make sure you take note of that density. It will also be on the print. And if you are using SolidWorks, then it's just going to be one of the out-of-the-box materials. All right, let's get into it here with our first challenge in a long time. Not going to be a difficult one, but I figure this will be going to warm us up a little bit. Here we go. This one is called TNG 001 Rivet. Rivet. So here we go. The challenge is live. Your challenge is to take this model, this 2D print, and what I would encourage you to do is take a screenshot, because we are going to move on in just a moment, and turn this into a 3D CAD model using the CAD system of your choice. And once you come up with the mass of this model, you can see up in the upper right corner, this is IPS for the unit system. So what is the mass of this part in 0.00xxx LBS? And please answer it in 5-place decimal precision. Don't just type in the last three numbers. Type in 0. Or you don't have to type in the first 0 if you don't want to, but type .00xxx. That way everybody's playing from the same disadvantage. Cam Smith has already modeled this part up and come up with 10 pounds. So excellent as far as speed goes, Cam, but unfortunately that is the incorrect answer. So this one is still open to everyone. 10 pounds is not the correct answer. But great job modeling it up so fast. I think maybe you want to check your units or your material or some of your dimensions. And we can see that Cam has corrected in the chat to say 10.00000. Very nicely done, Cam. Still incorrect, but very nicely done. All right, I'm going to leave this print up on the screen for just another moment and give you guys just one more moment here to grab a screen capture. You can use snipping tool, grab a screen capture. We're looking to find out what the mass of this part is in pounds. And while we're doing that, we'll take a look at the chat again and see if anybody else is chiming in, see how everybody's doing. Gerben again says, long time no see. When I first read that, I thought you said long time no solve. Long time no see. And Ray is here. Ray, I am very glad to see you again. Welcome, welcome. All right. I think we're pretty much caught up with the chat here. Everybody's still getting used to being back on Model Monday Live. One of my favorite times of the week. I think we're going to take Monday nights back because I really enjoy these times. I know I've had some people from other continents letting me know that they maybe are struggling a little bit with the time difference. So maybe there will be a point in the future where we can do these a little earlier in the day. But, you know, for now, we're going to stick with Monday nights because this is a night that I think it just kind of like sets the tone for the rest of the week. And we got celebrity Mike Puckett, certification master guru in the crowd. What is up, Mike? Thanks a lot for joining us tonight. Guys, say hello to Mike Puckett if you are out there and you know him, or even if you don't know him, still say hello. Wonderful to have you here in the chat, hanging out with everybody tonight. All right, so let's get back to the plan here. So the plan is to create this assembly, and this assembly is going to start out with this rivet, really, and the washer. We're really going to take the rivet and the washer, and we're going to put them together. So the rivet, you guys are all modeling up that rivet right now, which is great. I actually already have it modeled up, but I don't have the washer modeled up yet. So I just took some quick dimensions of this washer. I think the rivet has a shaft of about 0.125. So I made the washer with a inner diameter of 0.15, outer diameter of 0.5, and a thickness of 0.03. So we're going to go through, we're going to take a look at what this maybe looks like modeling this up. Not a very difficult part, but modeling this part up in SolidWorks. So we're going to go here to New, and we're going to choose our material. I'll just make this washer out of plain carbon. IPS, top plane, begin to sketch, orient the view. And then I'm going to click in the background, press the S key on my keyboard and launch the circle command. Single click, move my mouse away, type in the outer diameter 0.5, repeat, single click on the origin, move my mouse away, 0.15. And we are getting back into the swing of modeling. It's been a little while, guys, and it's great to be back. I think I'm going to make this thing mid-plane. Again, just to kind of set me up a little bit for the assembly, because I think I'm actually going to just drop this part right into the assembly. And on that note, maybe it even makes sense for me to assemble this in a different orientation. I think I'm going to assemble it like this, almost like upright, and just drop that washer right in the center. So we have to do a little edit sketch plane, right? So right mouse button here, edit sketch plane. So that's on the sketch itself, not the feature. Edit sketch plane, and then we're going to jump that to the front plane. And that way we have our washer nice and centered there on the front plane. Now, when I go to save this thing, what I'm going to do is I'm going to name it with a prefix. This is something that I do a lot of times when I'm creating models that belong to a project. Depending on what you're working on here, you might have this automated in your PDM system. But if you're just doing stuff on your own or with a small team, this is kind of a cool way to make sure that everything that's related to one project all stays together. It also sets you up nicely if you're going to do a pack and go later. So I just come up with a basic prefix, in this case TNG. It's a little combination. It stands for Tong, like the Fireplace Tong, but it's also a shout out to Next Generation for all of my Next Generation fans who are out there tonight. So if you like Next Generation, put your favorite character name in the chat, and we'll see if maybe there is a clear winner. I definitely have a clear winner myself, but I will save my answer to the end so as not to influence anyone. So if you are a fan of Next Generation, put your favorite character name in the chat. I'm going to name this thing TNG-002 washer, save, and then I'm going to do a file make assembly from part. And when I go to file make assembly from part, I'm going to choose my assembly template. And I'm going to single click on the green check mark, which takes the origin of that washer and drops it on the origin of the assembly, and also aligns the front, top, and right planes. So just kind of setting me up with kind of where I want this thing to be starting out here. I have not yet modeled this assembly, but I did kind of come up with a plan in my head ahead of time, and I think that it'll really pay off in the long run if I at least start with that plan. I don't necessarily have to stick with it, but at least start with that plan. So we're going to go here, TNG again, and we're going to go to TNG. This time I'm going to call this one 1001 because it's an assembly, and I'll call this Fireplace Tong assembly. Table 36 says, what is Next Generation? Next Generation is a Star Trek reboot that I think started airing in 1994, I'm going to guess. It is a Star Trek reboot. Might have been a little earlier than that, actually. It was somewhere around there, early 90s, mid-early 90s. Star Trek reboot, ran for 7 seasons, and just some great life lessons throughout all of the episodes. Alrighty, let's go on here and let's insert the rivet. So I had modeled this rivet earlier today, so I'm able just to press the R key on my keyboard. Vicky Chong knows about Next Generation, says Picard. That's an excellent answer, says Picard. So what I'm doing here, let me just flip over here for a second to my keyboard cam. So what I'm doing is I'm just pressing the R key on my keyboard, just the letter R, and that brings up my recently used documents, recently saved documents. And so from here, what I'm able to do is just drag and drop that rivet right into my assembly. So it's just instead of like insert component, browse, or anything like that, you can just press the R key and kind of simplify that process. So now what I'm going to do is pick this face, hold control, pick this face, let go of control, and then make that concentric. And then I am going to, I think in this case what I'm going to do is I'm going to actually make a width mate. And this is kind of a cool little trick that you can do with the width mate. You know, normally you think of a width mate of centering a smaller component inside a larger component, but you could also use it as kind of a shortcut to get some symmetry. So if I take this face and this face and this face and this face, and I let go, and then I say width, you see how it kind of like doubles as a symmetry type of a scenario. So you could use width mate for that, which I think is pretty cool. I'm gonna hit escape here. I'm gonna cancel that. Or the other thing that I could do is I actually could use symmetry in this case. So I could take the front plane of the washer, which is going right through the washer, and then I could hold control and pick this face and this face, and then I could assign a symmetry mate. So normally you would think of symmetry as like having two parts that move together, like maybe we'll do that with the tongs. But in this case, I could use symmetry to, once again, center the rivet and the washer, or center the rivet about the washer, or center these two faces, you know, about a plane. So instead of having two parts that dynamically move, you could also use it to quickly find the center of a part, because in this case, the rivet here you can see is not mated, or is not designed with this plane going right down the center. Like, it wouldn't really make sense to do it that way anyway. So with that, let's just add one final mate. Sometimes I'll do this just to kind of get rid of the minus sign. It's really not necessarily a best practice, because you're kind of adding an extra mate that you really don't need. It's not really helping you at all. But sometimes I'll do it just to get rid of the minus sign, especially for a part like this. It's kind of like the anchor of the rest of the assembly. So I'll take the plane of the rivet and the right plane of the overall assembly and just make them parallel or coincident, either one. And you can see that that gets rid of the minus sign in that component. Just means it's under constrained. It's not the same as having like an underdefined sketch in sketch mode, but it does give you just a little bit of kind of peace of mind. Now you know that that part's properly anchored down. Now I'm going to do a Control S for save, and we're going to be able to move on and talk a little bit more about this assembly. So some other answers coming in here. Number one, Table36 says number one. Table36 went from not knowing what Next Generation was to knowing the nickname of Will Riker. So that is very impressive. Tom Smith says Data, Lieutenant Commander Data. Yes, another excellent answer. And Steve says not a reboot, different time and different crew, different Enterprise, different crew. That is absolutely correct, Steve. I stand corrected, and I 100% agree with you. You are correct. Appreciate the correction on that one. Puckett says Dr. Spock. Excellent guess, but that was from the original series, TOS. And Cam says Dr. Crusher. She's actually probably my least favorite, Cam, so negative 5 points for you on that one. And Raju says the music is loud. I appreciate that, Raju. Let me see if I can just bump that down a little bit more here. Here we go. Let's see if that's a little bit better. Thank you very much. Appreciate that. It was a little bit loud in my ears as well, so that's a bonus of 25 points for you, Raju, for that answer. Would you use lock rotation in that case to fully define, says Table36? So that's a great question, and it would kind of depend on what I'm trying to accomplish. In this case, there's a possibility I'm going to use this plane downstream somewhere, the plane from the rivet. So that might be a reason why I would go one way or the other. Like if I think I'm going to use this plane to do a centering function or maybe a symmetry function, then I would lean more towards actually locking it so that that plane is vertical. It's going to really depend on the scenario. You could use lock rotation as well, or you could even just leave it free. So I don't really have a good answer for you there, It's a great question, and it's just going to depend on the scenario, table 3.6, but excellent, excellent question. And Cam Smith coming back through with Wesley Crusher, Will Wheaton. All right, yeah, okay. Good recovery, Vicky Chong says. Yep, I agree. That's going to change your score back up to positive 15. So good answer there, Cam. Wesley, I will definitely accept that. All right, let's move on here and talk a little bit more about SolidWorks, and let's talk about the next feature that we're going to be working with here, and that feature is going to be for the actual handle. So when it comes to creating a model like this, a model like the handle here, what I'm almost certainly going to do is work from a picture. This is something that if you've seen any of my other content, you know that I talk about this a lot. I think that making a picture, even in a scenario like this, just saves you so much time and so much measuring because, this isn't just a straight slot here. It's angled. There's a slight angle here, and then you're going to have to figure out what this angle is. You're going to have to figure out, what this straight section is and then what that angle is. And you could certainly use some type of square or protractor to ultimately figure that out. But it's just going to be so much easier if you work from a picture. So a lot of times what I'll do is I'll lay down something that has defined measurements in it. Like I've got this carpenter square here, speed square. I'm going to lay that down next to the model, and then I'm going to use that to help me determine what the appropriate scale is of the model. The other way that you could accomplish this would just be by taking some basic measurements and then dropping the model in on those measurements. So I'll show you both of those techniques because both of them will work out pretty well in this case. So what I'm going to do is I'm going to get in here and take some pictures, and I actually have already done this. I've taken some pictures here of this model, and what we're going to be looking for is a spot where we're more or less looking straight down on the model. Now, I actually didn't get a super good picture of this because the way that I was holding the camera just wasn't optimal for this. But what you can see here is that you can see the top face of the model here in red, but you can also see the side face of the model here in green. So this wasn't a top-down, straight-on picture. Compare that to this area over here. You really can barely see either of the side faces. It's almost perfectly straight down, which means that I'm not skewing the image, which means that I'm going to get more or less accurate dimensions. This is really bad, right? This is telling me that I was at an angle when I took the picture, which means that if I'm trying to use this as my template or as my layout for my actual SolidWorks sketch, my dimensions aren't really going to be that reliable. So this is something you always have to be aware of when you're trying to work from pictures. Sometimes if the model is very elongated, you just have to take pictures in multiple sections of the model in order to get the desired results. So, in the case of this print here, you can see that I got a pretty good shot of this area down here that's actually curved a little bit. I might not have realized that had I not taken this picture, but this area here actually has a little bit of curvature to it. So that's going to be very useful, but maybe that other region is not as useful. I'm not going to go quite that far with this example tonight. I do have this picture here, which is a lot closer. Still has the problem here in this region, but definitely a lot better in this region here. So I'm just going to take it and say that this is going to be the one that I'm going to keep and that I'm going to work with. And hopefully we can also see down in this region the curvature of that part. So I'm going to take this this model here, this image here. I'm going to open this in a photo editor. I use paint.net. It's a very capable, very affordable photo editing piece of software, so it's kind of my go-to for doing any kind of photo editing. If I was doing, more and more photo editing, anything more professional, I probably would opt for something a little bit more capable. But what I'll do here is I'll make a new layer. So just like you have in like AutoCAD, you can make a bunch of layers here. Even in SolidWorks, I say AutoCAD because I think that's where we all learned layers from, but you can also do layers in SolidWorks. I do that in drawings a lot. But you can get in here and you can see you can create different layers. And when we create these layers here, I'm going to just create a line that is exactly vertical. So just a simple line here that is exactly vertical. And then I'm going to use that line to align the rest of my image to it. So I go back to this first layer, select everything, do a move command, and then I can rotate this first layer until I get this line to be perfectly vertical, so that it's kind of matching up with that other line that I created. This is just going to set you up in SolidWorks. You can do all this stuff in SolidWorks, but if you do it here, like, you're ready to go as soon as you come into SolidWorks. It seems like a much better solution to me. But you can certainly do this in SolidWorks as well. Now I'm going to delete that extra layer that I created that gave me that line, and then I'm going to finish up by just cropping this and finally making the image a little bit smaller. The resolution for this image is a little bit large, and if I embed that large image into my SolidWorks model, I'm going to be increasing the file size of my SolidWorks model, and that is not what I want to do. So I'll do image crop to selection here, 1700 by 20 by 2000. Maybe I'll just make it a little bit smaller, image resize, and maybe just make it like 1200, just a little bit smaller. Okay, and now I am going to file, save as, and I'm going to save this as, let's make a new folder here. We'll call this one cropped images. Okay, and we'll call this one handle cropped. And now we're just going to do the same thing with the grabber. So let's see here. You know, just like we did before, we're going to kind of zoom in, see if we have a good one where we're looking down from the top. Look at this. We got almost, almost nothing on the side there. Almost that one's got a little bit on the side. Let me see if I have a better one there, since that's the one that I'm measuring to. That one's pretty good. Let's see. I'm not sure if I like that one. Oh, yeah. There we go. That's a winner. So you see that I can't see anything on the side here. I can only see a tiny bit here, tiny bit on the side there, but other than that, can't really see anything. So, I think we are good here. All right, and let's see here. JMG is here. What's up, JMG? Thanks a lot for tuning in. Glad to have you back. Thanks for the kind words there. It says miss the channel a lot. And John is here as well. What's up, John? Thanks a lot for tuning in. Great to see you. And welcomes and applause from everybody. It's awesome. All right, so here we go. We're going to take this and we're going to say open with. And once again, we're going to use our very affordable photo editing software, Paint.net. And then once again, we're going to add a layer. And we're going to take a straight line. So I'm just holding the shift key here when I'm making the straight line. Shift key, just to give myself a nice straight line there. And then go back to my first layer, Control or A to select all, M key for move. So first you select everything and then you can move it. And then you can see we can kind of adjust this thing into position. And again, you can do this in SolidWorks. But I just think it's so much easier to do it here. And that way, when you bring it into SolidWorks, you kind of know that you're more or less aligned with what you're trying to do. Now, do we think that this and this are supposed to actually be in line, or is there supposed to be a little gap there? I mean, it's one of these things where this tool has clearly been used, and over time, it probably did widen a little bit. So, that's something that maybe we want to just keep in mind when we get to the actual design. All right, so let's get rid of that extra layer. We'll delete that extra layer there. We'll do a crop here. So a little S key in Paint.net as well, but this time it's for select. And then we will do a resize and just make that a little bit more manageable again, just like 1200. Whatever. This is something that you have to kind of decide based on experience. All right, so we'll call this one grabber cropped. And we now have our two images to use as part of the design process. So let's jump back into SolidWorks now and make one of those parts. So we'll go here to a new part. We're going to use inches here, and I'll just use my plain carbon steel template. But, I'll probably change this material to like an iron. I'll stick with steel for now, though. Front plane, begin to sketch, orient the view. And now here what I'm going to do is I'm going to create some geometry that I can physically measure. So I'm going to come up here with an arc like so, and I'm going to physically measure this. Just on the model itself here. Got some calipers. And I'm going to just take basically a tangency to tangency measurement here. Okay, and I set my caliper to inches. Looks like about 1.62 tangent to tangent. So from here to here, 1.62. And then, like I said, I've got that speed square in there, so I could also draw a 6-inch line here and just kind of assign that, or align that to the speed square as well. So now I've got two different points of reference in this layout sketch. So I'll just call this a layout for scale. And then what I'll do is I will go to the sketch color here. So right mouse button, sketch color. And I'm going to adjust this to something that I can see once I drop in that image. Because remember, I'm going to be putting that image here on top of this. I don't want it to be gray. I don't want it to be the default SolidWorks sketch color, or it's going to be very difficult to see. So now I'm going to go here to Tools, Sketch Tools, Sketch Picture. And once I go to Sketch Picture here, I'm going to jump to our project. Here we go. And into the cropped images. And we're going to grab this handle, cropped image. And this is something that I've talked about before in various videos that I've made. But when you bring in this image here, the default behavior is you're going to start out with this little scale tool. Now, the scale tool is pretty cool because what it lets you do is it lets you drop that line onto something that maybe you already have as a reference. So, for example, I could take this line endpoint here, drop it here. I could take this node here and drop it down here on the 3, like so. And then I could say that that distance is supposed to measure 3 inches. And then when I hit enter, the entire picture resizes to match that value that I just put in. So that's the scale tool, and it can be pretty useful. And I mean, you can see here how accurate it got. If I move the green line here to kind of the edge of the speed square, you can see that the end of the line is pretty close to the 6. It's maybe like a fraction off, but we're working with images here, right? So that's one way that you can utilize your layout or utilize that tool. The other way that you can do that is just by unchecking that option for scale tool. So here's the enable scale tool. And now you can just drag the corner of the print and you can resize it. But hopefully, if I drag this over here, I don't even have to resize it. Sure enough, look at that. That really fits nicely. Like it just fits right in there. Exactly what I was expecting to get there from putting in, that dimension, that tangency to tangency dimension in my layout. So I'm going to say that this thing is pretty much good to go as far as scale goes. And now it's just a matter of deciding kind of where I want this thing to start. Like, where do I want the origin on this part? We could make the argument that maybe the origin should be here. I mean, the other part has the origin here. So I could probably get on board with that, having the origin right here. And then kind of working from there. There's going to be a few different ways that you could do this, but I think that works fine. I can just put the origin, more or less right in the center there. Maybe what I could do is go back to my layout sketch, and I could say that I want that dimension to be the dimension of the rivet. So that dimension of the rivet, I got to remember what the print said. What was it, 0.375 for that rivet? It's pretty close to that, I think. And then I can use that to kind of make sure that I'm nice and centered there. I'd have to double check to make sure I had the dimension right. But, so you got a couple of different options here as far as how you're going to lay this thing out. But I think that should pretty much work for me. So at this point, I'm going to hide the layout that I had created. I don't need that anymore. I could even delete it. And then I'm going to rename this one pick front of handle. And now, it's just a matter of doing a basic extrusion, right? Just a thin feature extrusion is how I could handle this. Now, we could do this as surfaces, or we could do it as an extrusion. You could definitely go either way on this one. I thought a lot about this, about whether I would do this as surfaces or do it as an extrusion. But I think I'm going to do this one as an extrusion. So I'm going to go here to front plane again, begin a sketch, orient my view, and I'll start out here kind of at the point of tangency, and single click. Move my mouse up to this point, single click again, come back and touch the end point, come up and around, kind of get that arc there, single click again. Now I'm going to be coming down at not vertical, but at a slight angle, right? What's this radius here? I mean, we could get a radius gauge and we could measure it, or we could just use the image, right? Take advantage of having the image there. And then finally, we'll come down here with this line at an angle as well, and then just a little bit of cleanup here. So we can get that point like so. We could maybe add an anchor dimension from that point to the origin. So 3.375 to that point, horizontal dimension as well, like so. So we'll say 0.6. A lot of times, you know, if you're going from an image, you're going to be more or less using your best judgment. So, you know, don't worry too much about the dimensions being exactly what the image was. Like, if, you know, it depends on what you're doing, but if your goal here is to come up with a new product that's similar, or maybe you're trying to make a new rack, or you're going to design a holder for these tongs around your fireplace, well then, you know, it doesn't have to be plus or minus, you know, a micron. You got some tolerance there, so don't worry too much about getting the dimensions exact. So, you know, I'll come in here, maybe make this 139, maybe 138. You can see here that we can just, you know, we can just kind of adjust this and again, use the image to our advantage to get this thing, you know, pretty close to what the physical model is representing here. Okay, now this is going to be a tangency point here. And we'll bring this guy over like so. And again, we can put in an angle dimension there to kind of lock that down. I just put a vertical center line there to get that angle dimension to what it needs to be. As far as the location of that, I think we're going to find that we're going to be able to get that by dropping in this location and then assigning the radius up top. So that's how I'm going to handle that. So again, just kind of anchoring this off of the origin here, anchoring this from that origin line that I created, and then finally putting in this radius. What did I originally have that at? 1.6. Yeah, okay. And then we can just get this final location here. And for this final location, you know, again, we can just take the center of that, move it over here. You know, you might be asking yourself, why even bother fully defining it if you're building it from an image? Well, the reason why is because if you do, you know, if you are using this for some kind of downstream design application, this is going to make it very easy for you to slightly tweak the design so that you're able to, you know, keep moving forward with the design process. So now, like I said, it's just a simple extrusion. So we'll zero out our caliper here, and we'll say that this has a wall thickness of about 0.15, and it has a depth of about 0.58. So we'll go here, S key extrude, thin feature here, 0.15, depth 0.58. And now here's where we get to the final kind of sticking point on this thing, which is what's the delta between the twist and the original. And I guess I'm going to say that that delta is right down the middle. I mean, yeah, I think we're going to say it's right down the middle. It's pretty darn close to being right down the middle. It looks like it might favor the one side, but man, it's pretty close here what I'm measuring. I know I apologize, I'm a little off camera here, but I think it's pretty much right down the middle. So I'm just gonna call it as being right down the middle, and take that 0.58 and that 0.15 and just kind of split it right down the middle, and then I'll use that same value in just a moment. You'll see in just a moment why that's important. So we'll make that mid-plane. There we go. That takes care of that region. And now we just need to do the other region. Whoops. I extruded it to the wrong side. Let's flip that thin feature. There we go. And now we just need to do the other region here. And this, again, is just going to be basically simple tracing. Go front plane, begin a sketch, orient my view. I could say that I want this value here to be 0.125 for that rivet. I can say that I want this value here to be the same. Looks like I was intending for that to be vertical, but I got slightly off, but that's okay. A little bit of an arc here at the bottom. And then finally our remaining closing feature here. How far off vertical am I on this thing? This is vertical. That's pretty far off because I didn't quite bring in that print the way that I'd hoped to. That's all right. So then at this point, you know, you're going to have to make a decision here. what you're going to do with this design at this point. You know, are you going to leave this, you know, kind of off center here? I'm not going to do that. You know, I'm not going to leave it off center. I'm going to make it vertical because it's just more appropriate for this type of design. So I'm going to capture what the distance is here, either, you know, via dimension, or like I already know what it's supposed to be, right? It's supposed to be 0.58 per the other region. I can measure it here again just to confirm, but yeah, it's coming up as 0.58 exactly. So, you know, clearly my photo is a little bit off, but that's okay. You know, it's for this type of a design, for what we're doing here, it's acceptable, and you're going to see that it's still going to work out. And there's always ways that you can resolve that too, right? Like one way that we could resolve that would be to maybe go back to the original print and just adjust, or the original picture, excuse me, and just adjust the original picture to compensate. So we could take this original picture here and just adjust the angle slightly, maybe increase it or decrease it by like a smidge of a degree. And then what we'll see is that that line will become vertical. We could also include that in the layout. So when we go to the layout here for the picture, we could include that as well. So there are ways that you could get this thing back to being on square. And, you know, if we had a little more time, I probably would spend a little bit more time trying to get that perfect. But I think that at this point, I'm just going to adjust that maybe a little bit further, maybe like a -0.4. Again, line this thing up with the center, and then we should be good to move forward here on this guy. There we go. That's going to be close enough. So now we're going to edit that sketch again. We're going to create a vertical center line here. That's going to allow us to hook this directly to the origin so that we're exactly centered on the origin. We're going to indicate our distance to flat here, which you're kind of eyeballing it up, trying to measure the tangency here. You know, you just have to kind of do your best to figure out where this transition is going to be and what's going to give you enough room to come off tangent, which you'll see in just a moment. And then similarly here, we could take the origin and this point really, and make them all vertical. And then we could just put in a couple of final dimensions, like what is the radius here, or maybe what's the distance from this point to the peak. A couple of options there. Just make that a radius 1. And then what's the distance from here to the origin as well. Final dimension is going to be the distance from hole to hole, which, you know, obviously will be very important and will definitely need to be adjustable. Look at that, 6.99. I think that's perfect. 6.99. Couldn't be more reasonable. Alrighty. So now we're going to take that and extrude that once again mid-plane and to our height of 0.15. And that's it for our layout. We really don't need to see that layout anymore. We've got the handle region. We've got the straight region. And this is something that, you know, you guys have probably heard me talk about this a lot, but like I'll come in here. I'll call this one handle section. I'll come in here. I'll call this one straight section. And then I will immediately Control S for save. And, you know, just kind of, that's like my routine. You know, I'll rename a couple of features and then I will just immediately go in here and save the file because my hands are already on the keyboard. So it's like rename, go to the next one, rename, go to the next one, and then Control S when I'm done so that I can save that file off. So now for this final region here, what are we going to do with this final region here? Well, what we could do with this final region here is we could go to the loft command and we could say that we want to loft from this face to this face. And then what we could do is we could say in the definition of the loft that we want to start with tangency and that we want to end with tangency. So if we grab, actually I think I wanted to grab this node here, right? There we go. So if we grab the correct node, then we can see that that gives us the result that we want. But not only does it give us the result that we want, it ensures that this face blends into this face with tangency. So this face here blends into this face up top with tangency, and this face here blends into this face with tangency, and the next face and the next face as well. Now, the reason that's so valuable is, you know, not only does it give us the result that we want, but it also means that we can then right mouse button, select tangency, and then perform a surface offset surface command, and we can offset that surface at 0. And then what we could do is we could hide the solid body, and we could take that surface body and we could choose a surface flatten command. So we could say that we're going to take these sections, which are all tangent, and again, we could do this with a right mouse button, select tangency, and then we could say that we're going to hold at maybe this location, and we can actually generate what the flat pattern will look like. And if we increase the accuracy here, we will increase the mesh density, and that's going to give us even more accuracy. So we could increase the accuracy, increase the mesh density, hit the green check mark. Now we've got a flattened surface here, so we can hide the original surface, and then we could take that flattened surface and we could perform a thicken, and in this thicken command, we can make that 0.15. And so now we've got ourselves a, potentially a flat pattern configuration. And then if we were to suppress all these features, we'd have a formed configuration. So there's the formed config, and we could go here. We could call this one formed config. And then we could go right mouse button, add configuration, flat config. And then in the flat config, like I said, we would unsuppress these, and then we would insert features, delete body, and we would delete this body here. So now we have formed and flat. Now, when I did that formed, I went with the outside faces, which I know is wrong. Really, I would probably want to do it with some of the inside faces, or maybe I could even, when I did that offset surface, maybe instead of doing the offset surface at 0, so let's go back to that offset surface. Surface offset here at 0 exactly to the outside. Maybe I would do it at like 0.1, 2/3 of the way through the wall thickness. So 0.1, the wall thickness is 1.5. So you see how that gets me like 2/3 of the way in. That's probably going to yield a more realistic flat pattern. It's not going to be as good as doing something with sheet metal where you're actually doing a K factor and factoring in your deformation, but it's pretty close, right? It gives you something that's going to get you pretty close to what you need to work with. And, for this type of work, I'm sure that they're going to be, whacking this thing with a hammer. I think that's what they officially call it in blacksmithery. Just whacking it with a hammer. So, yeah, there you go. There's your handle part. I think that part came out pretty good. Let's adjust the material here. If you guys like that one, give me a 1 in the chat. Make sure that you guys are enjoying this. I'm hitting all the right notes here. 3167 says, only reason I fully define is I heard a song about it. A great song indeed. Welcome back from the grocery store, 3167. Great to have you here with us tonight. All right, let's assign the, let's just make this thing out of like a rubber. Malleable cast iron. I don't know why I said rubber. Out of an iron. Malleable cast iron. And then let's take this and save it. Control S. Let's go to our assembly here. Let's do, you know what? Let's do a mate reference on this thing just to make it a little bit easier. So this is a good trick if you know you have a peg and slot type of a scenario. So like this edge here is at the intersection of a cylinder and a planar face. So I can take this edge here, then press the S key on my keyboard, and then go here to reference geometry, mate reference, and then I can just hit the green check mark. So this is a mate reference using the default reference type, default name, default reference type, everything default. All I did was pick this edge. I'll do it again. Pick this edge, press S on my keyboard, reference geometry, mate reference, and then hit the green check mark, which I could even do by doing a right mouse button. Okay, now I've added a mate reference to that edge. Now, what does that do for me? Well, what it does for me is it sets me up so that if I go to the assembly and I can see this edge here, which is at the intersection of a cylinder and a plane, what I can do is I can press the R key on my keyboard and I can drag in this handle and then put my mouse over that edge, and SOLIDWORKS just mates those together using both a concentric and a coincident mate. Pretty cool, right? That's a mate reference. That peg and hole mate reference is a great time saver if you can remember that it exists. So I can do the same thing back here on this side. I can do the R key, grab the handle, drag and drop, put my mouse over that edge that exists at the intersection of a plane and a cylinder, and once again, I get two mates for the price of one. Whoops. Why didn't I get the 2 mates for the price of 1? 0 mates for the price of 1. Let's try it again. R key, drag, drop. Okay. Okay, there we go. 2 mates for the price of 1. And now I can put this guy here like so. And so this is what I was wondering about was, you know, these are supposed to, it's kind of interesting how these are supposed to come together. Like they're supposed to come together kind of like this, but obviously these don't right now. So I wonder if the loft direction was incorrect. You know, if I just took it in the wrong direction there. So if I go edit feature, and then I look at this node here, and I drag the node up to here. Oh, nope, that's not what I wanted. To here. And then maybe if I drag it over to here. That doesn't want to let me. Okay, let's try this again. Let's delete this face here. Let's delete this face here as well. Might be that tangency constraint that's getting a little bit funky. Great, now I lost my perspective. I don't even know where I am anymore. Okay, let's try this like this. Select other. Get this face here. Okay, and then we're going to do tangency to face and tangency to face. Okay. So I took that twist and bent it the other way. Let's go back to our assembly and see how the assembly looks now. There we go. That's what we wanted. So now you see how those kind of like mate together. It was something that I thought was pretty interesting about this design. Is that the way that that comes together kind of up top there. You can kind of see that. Oops. This is hard to do. Right there. How they kind of like nest together. So that's pretty cool. I think we got that in the design as well. Wasn't sure how that one was going to work out, but that I think looks pretty good. They nest together pretty nicely. I wonder if they do something with like an offset of the holes to allow it to actually, you know, completely come together. Like if maybe this hole isn't exactly vertical in that straight section. If this was just a little bit off here, it would be off. If in the straight section here, if I took this hole and it wasn't exactly coincident, it's going to get a little bit gnarly with that vertical line. That out of there. Let's think. I wonder what kind of downstream effect this is going to have because I have this vertical relationship to this guy and this guy here. Let's get rid of that one. Okay. So I'm going to make this, which is the arc, vertical to this, which is the origin. Vertical. And then I'm going to make this vertical line here to the midpoint of this. And then I'm going to make sure that this dimension is coming from the origin as well. See, this is the problem with having a hole right on the origin. This is why a lot of times I'll make those holes kind of in their own sketch, so you don't end up with all these dependencies. But now I could say that I want this center of this hole to be over by, say, 15 thou. Nope, I did 150. Still pretty rusty here. Still pretty rusty. Not going to be winning any contests with these moves. All right, and we'll make this guy here vertical. All right, now let's see if that sets me up a little bit nicer with that nesting scenario. That's a little bit nicer. I think we could probably still go better, but now we have that nice dimension there that we can just adjust here in this view. So we could say that we want that to be, oops, let's make this IPS. We could say that we want that to be maybe 30 thou. Oh, it's getting worse, huh? It's going the wrong way. No problem. reverse direction. Wonder if I can do that from out in the assembly mode. If I don't know if I had to go into the sketch there to do that reverse direction. There we go. See, look, now that's nesting together a lot nicer. So I wonder if that's how they do it. I mean, it looks pretty centered on the physical part, but I'm just kind of curious since we have the the mechanical model here. Why not try it? All right, cool. So now what we could do is go on to the next model, and we're just basically going to rinse and repeat here. So new, and we're going to make this part in, let's see here. Killing it in my book. What's up? A very swell idea. Great to hear you in here. Chris with Cat is in here as well. Love mate reference. Use them on my own custom fasteners. That's awesome. Welcome, welcome, welcome. You know what? We got some new people in here. I think I'm gonna deviate from the plan a little bit here. Give you guys something else to chomp on here. I need to go back through the chat and see if anybody got the answer to the first one here. So it looks like Tom Smith came in with an answer, 0.00268. I'm just kind of rolling back through the chat here. And Tom, it looks like you're the only one who answered it, and you did indeed get it correct. So very nice job. Very well done. And I'll tell you guys what, let's do another one. Let's do another modeling contest here. So once again, this is just for fun. This is just to challenge you a little bit, to knock some of the rust off. Let's do another modeling contest here. This one is going to be called Poker. So let's do another modeling contest here. We'll stick with the fireplace theme. I know there's been a couple of people who have been able to get into the live stream here. This is going to be a model using the same units that we always use, same densities that we always use, and the density will be on the print as well. So let's just get right into it here in 3, 2, 1, go. So you can see here, this is a poker, a fireplace poker. And you can see that the fireplace poker here is utilizing all dimensions to center lines. And I spelled dimensions wrong. So there you go. That's only a term that I use 50 times a day. No problem with spelling it wrong. I also don't think you would ever get a design like this with the dimensions to the center lines. But it was just getting a little bit too cumbersome to dimension everything to the outside. And I figured I'd give you guys a little bit of a break. So if there's a dimension on there, it's probably to the center line. I mean, not every single dimension. Like, obviously, the diameter dimensions are not to the center line. But everything else in there is to the center line. So be sure to take a screen capture of that. We're looking for the mass of this part in grams. XXX grams. We'll see if Cam can model this one up faster than everybody else like he did last time. And I'll give you guys a chance to take a screen capture and start modeling that up. And I'll leave this up for about 10 more seconds. All right. I hope that was enough time. Cam says he's watching football. Awesome. Awesome. All right, let's keep going here. So that model there that we just looked at was the handle, right? We were able to kind of come up with a plan for the handle there using an image. So let's do the same thing here with the gripper. So we've got the image of the gripper here, and we're going to try and find a good print of the gripper. We're going to crop that image so that we can bring that image into SOLIDWORKS. We've already done all of that. So now it's just a matter of jumping into SOLIDWORKS and utilizing that image. So let's take a look here at our SOLIDWORKS environment. Let's go new. We're going to make this a new part in inches. And we're going to go front plane, begin to sketch, orient our view. And once again here, we can take a physical dimension off the part. So we've got our, we've got our width here, right? Which is once again, this 0.58 for our width. So that could certainly be a physical dimension. And then we've also got this kind of top to bottom radius. Kind of tricky to figure out what that is, but we'll go with just 3 inches on the nose for that one. I think for this one, I'm probably going to just do the 0.58, right? I think it makes a lot of sense to kind of just start there. So, you know, we learned our lesson from the last one that maybe we don't want that hole to be directly on the origin. So maybe instead this time what we'll do is we'll make that 3-point arc, and we'll just kind of center that relative to the origin, and then we'll do our 0.58 dimension here between these 2 lines. So, you know, just kind of mixing it up a little. I think if I was modeling this for an actual project, I'd be a lot more consistent in these techniques. But in this case, I think I'm just going to kind of mix it up a little bit just to experiment, see which one maybe works a little bit better. So we can make that horizontal, and then we can say, you know, what the radius of that was. I think last time we said it was a radius of 1 inch, so let's just stick with that again, because we're not really going to be basing this off of that dimension so much as we will be off of these lines here. So again, we can right mouse button here, sketch color, and change that sketch color to yellow. That's after you get out of the sketch. You get out of the sketch first, then you can do that. Front plane, begin a sketch, orient our view, tools, sketch picture. And when we go to sketch picture here, we're going to bring in the picture of the handle, which is now cropped. And like we said earlier in this segment, we were able to go to the little sketchy tool thing here. Sketch scale tool, I think it's called officially. Put that on one side of this line, bring this over like so to the other side of the line, 0.58, and now the entire print is scaled so that that dimension represents 0.58. It can be very handy if you know how to use it. If you don't know how to use it, you'll probably be like, what the heck am I even doing here? Unfortunately, I brought in the wrong picture, so I'm going to click on the picture, press delete, and have this on my other screen. And let's try that again. Tools, sketch picture. And we're going to do the grabber. And let's take a look here. Just like we did last time. Actually, let's bump this 180. And now we can take this end point here, drop it like so. This end point here, drop it like so. 0.58 is what that distance is supposed to be. And now we can uncheck this option for enable scale tool. Otherwise, if you go to grab this and resize it, it'll say the scale line controls the size of the picture. So enable scale tool, uncheck that. This little blue line will go away. And now you'll be able to rescale the picture. But hopefully we won't have to. You know, if I did good there, we won't even have to. Maybe I need to just a smidge. And my vertical looks like it's pretty much vertical. So that's good. We got that going for us as well. So now we can exit that sketch, and now we can just kind of finish building this thing, you know, basically the same way we built the other one. So I'm just going to trace the outside of this, and then I'll drop in some dimensions. Front plane, begin a sketch, orient my view. Done with the poker. Tom Smith says he's done with the poker, and he is going to wait to answer until somebody else does. That's very generous and kind of you, Tom. You are so good to the community. He is a master. Yes, yes, indeed. Okay, here we go. And we're going to trace this guy around here like this. Now, you know, I mean, this part is, it's probably formed on an actual machine, so we could probably get this radius to be, you know, pretty close. But if it was more of a freeform type of thing, if you're retrofitting to something that's more freeform, then maybe you would use a spline here instead of an arc. So, you know, that's definitely an option that's going to be on the table when you're taking pictures of things and kind of trying to reverse engineer from those pictures. So, you know, just don't necessarily rule that out. It may be the appropriate option, you know. And then for the remaining dimensions on this sketch, I think, you know, probably at this point what I would do is I would get this dimension here, this radius to be consistent with this radius over here. I mean, it does look like this one's a little bit tighter, but again, if you're manufacturing this, you're probably using a consistent set of tools. So I don't think it would deviate quite that much. You know, let's see if we can get this radius here locked down. So 1.7 for that radius, and then we're going to say that we want maybe just to locate the origin just for the sake of fully defining the sketch. Kind of just for the sake of consistency. We might locate the center of that arc. It's just going to make our life easier for the rest of the design if we can get that position kind of locked in and get that black. So now we could, get into things like what's this location relative to the origin. This is just kind of something that I'll do if I'm working from an image. I'll try to get, some of the lower hanging fruit locked in, and then I'll go back and define the rest of the features. And, something like this dimension here that's supposedly coming from the tip of this thing, I can just take a tape measure if I don't have a big enough caliper. And kind of confirm that dimension is coming out correct or confirm that it's coming out incorrect, right? So you've got these options when you're going through and you're working on these designs like this, working from an image, to continuously refine your dimensions and make sure that you are in fact getting the expected results here. So then now we're left with this final dimension here, and I guess, I think what I would probably try to do is get this a little bit closer to what the other one is. So if I make that, say, 0.3, can I bring this arc around anymore to accommodate that? I mean, it almost looks like it is supposed to be larger upon second glance, upon a closer inspection. So maybe I would leave that just a little bit bigger. But again, it's going to depend on what you know about the manufacturing process for this particular product. And if you know that they would be using consistent tooling, then maybe it wouldn't make sense for this one to be 0.25 and the other one to be 0.5. But in this case, I'm going to say that actually was intentional. And the final thing that I need to do here is just kind of lock in this final location. And the way that you do that, it could be done in a number of different techniques. But I think what I'll do here is I'll add an angular dimension to this value here, maybe with the center line from the origin. So I'll come down here with the center line from the origin, and then I could add an angular dimension to this line here, just to give me something to adjust if I, determine later that I need to make such an adjustment. And then again, finally here, what we would do is kind of see like, okay, why is this still moving? Okay, it's moving because of the horizontal location relative to the origin. So again, from that vertical line, I could create a horizontal dimension there. 0.169. I love it. It's perfect. Okay, so now we can extrude, S key, extrude, bring that out to 0.58, midplane, make this guy 0.15, and reverse direction, so it's going in the correct direction relative to what I had traced there. And now we can finish off here with front plane, begin to sketch, orient our view. And in this one, we can even just take our layout here and just reuse it. So convert entities from that layout, reuse it here, and just kind of bring it down to wherever we think that point of tangency is. And we can bring this straight across like so. Throw in a dimension here. Sometimes what I'll do if I'm zoomed way in like this is I will single click on the origin and then single click on this line and come over, and then I can put in my dimension. So I don't have to actually zoom out and go and find the origin. I can just single click on the origin from the tree there. That's usually a good little time saver. S key, extrude, and we're going to extrude this guy midplane as well, and 0.15. And let's save this. So we'll call this one TNG 004-grabber. And then again, we'll come over here in the tree. This one will be layout for pick. This one will be pick. This one will be, let's see here. This will be, I'll just call this one grabber end, grabber section. And this one will be straight section. And then again, Control S for save. All right. Awesome, awesome, awesome. Jay, what's up, Jay? Thanks for tuning in. Welcome, welcome. And let's see here. Chris was able to come up with 569.622. Tong came up with 573.066. You guys are very fast indeed. Keep those answers coming in. I'm not going to confirm or deny whether either of those answers are correct. So keep them coming in, and we'll see what everybody comes up with. And maybe this time what I could do is leave the image up just to help me with the blend. So I could do a loft here, just like we did last time. Features loft, and the loft is going to be from this profile. So I guess it's going to go from. Looks like it's going to go from this corner to this corner, and then we're going to say start from tangent C to face and end with tangent C to face. Yeah, that looks pretty good. That's, I think, what we were expecting. Sweet. All right, and and then the final thing here again would be to put in those holes. So in this spot, sometimes what I'll do is I will just maybe hide this body just to make it a little bit easier to see kind of where those holes are supposed to be. Front plane, begin to sketch, orient my view, and then drop in this hole like so. I'm going to learn my lesson from last time and make these a little bit off from the origin. This one actually does look like it's off, huh? So we'll make that 0.125, and we can make this. We could probably just do another center line here, right? To make it a little bit easier to visualize. And then we could say that this is going to be off by. See, when you have a center line, you can end up with a double dimension really easily. So we don't want that to be doubled. Go to here. 40 thou. And then we just need to get the height of this. Like so. So from the origin to here. 0.420. I think that's a perfect number as well. We're getting all the good numbers tonight. And we will make this vertical here as well. And then, again, input our distance between these two this time. Center to center distance here. 7.97. See how that looks? Okay, that looks great. And we'll just make sure that those are equal. All right, so now what we can do is we can show our solid body again. And S key extrude cut, and that's going to be through both directions. And I think that's pretty much going to do it for the grabber. We'll once again go over here to our loft. What would we call this? Loft section. Like, do we even really need to rename that one? Probably not. And then this one will be the two holes. And Control S for save, and we'll hide this. Hide this. Assign the appropriate material. All right, and let's take a look at our assembly here. And for the assembly, I wonder if we can do a copy with mates on this guy. So if we do, let's think here for a second. What's this going to be mated to down here? It's going to be mated to the same thing down here, right? So if we do a copy with mates, and we say we want to copy that component and this component. So I did a right mouse button, and then I did the copy with mates. We do these two components. We go next. Then we can see that the parallel, which was to that centered plane, well, that can just be reused. The concentric, which was to what? To this part here. That concentric is going to become concentric to this down here. The coincident, which is to this top face here, is going to be repeated. The concentric, what's that one to? Oh, there's a concentric to that lower one. Man, so if I had that other part in to begin with. Wow. This is going to be pretty cool, I think. Right, let's cancel. Cancel my copy with mates. I'm going to take my grabber and drag and drop it in here, like so. And my grabber and drag and drop it over here, like so. I'm going to hope that I have these oriented the correct way. And we're going to see if we can make some magic here. All right, so this one is going to go kind of here, and this one's going to go kind of here. And let's see what happens here. I wonder if this is, I wonder, I don't think it's going to work because of the mate that I put into the actual assembly. The grounding mate here. Yeah, maybe it still will work. Oh, I don't think it's going to work. All right, I'm going to try it once, but I'm actually kind of thinking this isn't going to work. Right mouse button, copy with mates. Could probably use it for the other 3, but I probably can't use it with this one. That's going to be my guess. So I'm going to copy this, and we're going to copy that from this first location. We're going to repeat the parallel mate. We're going to update the concentric mate to be to this face. We're going to repeat the coincident mate. We're going to update this concentric mate to this face. And we're going to update this coincident mate to this face. Okay? Hit the green check mark. And then we're going to update this concentric mate to this. Oh, no, wait. Not to that face. To this face. And then we're going to update this coincident mate to this face. And we're going to update this concentric mate to this face. And we're going to update this coincident mate to use the same face. Wow. That actually worked a lot better than I thought it would. So the only thing left is just to take this guy and mate him to... Oh, did I get a mate alignment issue? Let's see. I did. Rats. All right, well, we gave it a shot. We went for it. We're going to control Z here. I thought that first one worked great, but maybe it didn't. What do I have? Just a permanent mate alignment issue here now? What's going on? That's not what I wanted. That's weird, huh? Let's find that one. Coincident, flip mate alignment. All right, guys. Well, we kind of thought maybe it wasn't going to work out. It's okay, though. We can still get through this. This face and this face, hold control, coincident. This face and this face, hold control, concentric. Done. And this face and this face, coincident. And this face and this face, concentric. Done. And then finally, this face and this face, concentric. And let's see what we end up with. Oh yeah, looks perfect, right? So close. Control Z, Control Z, Control Z, Control Z. That's what I get for being too zoomed in. All right, third time's a charm for sure. Here we go. Last try, and then we're going to wind this thing down for the night. It's all good. Coincident. Concentric. Double check. Okay, hopefully that looks good. Are these gonna actually mate together? That's the question. This is gonna be on this side. Coincident? So I'm doing this pick one, hold control, pick the other. Concentric. And then finally, Finally. Concentric. Oh, come on. Why do I keep missing this? Are you guys in the chat telling me? Yeah, Tom says it's still backwards. Make the new parts first. That's a good idea. It's so awkward, right? Because it's yeah, I got it. It's just awkward because it's like this is the mate here to this one, and then it crosses over. Oops. It's just so counterintuitive for my brain right now, which is okay. I mean, we're winding down, so it's all good. All right, and then this one here is going to be the opposite as well. It's going to be this way. And I think we finally got it. I say we, but you guys probably had it like 6 iterations ago. Just took me that many times. There we go. We got ourselves a set of tongs. Look at that. Get some firewood. They even nest together down there the way we want them to. Look at that. So cool. So, and then the final thing with the rivet and the washer, if we take, you know, I'll do an abbreviated version of this, but if we take the washer, we bring it in, and we take the rivet and we bring it in, and then we were to say mate the rivet here to this location, which again, we could just do that with the mate reference, right? We could, oh, actually, I don't have the mate reference on this part. Let me add it to this part here. So pick this face here, S key, reference geometry, mate reference, use the default, save, close this part, R key, drag this part in. Now it's going to snap right into place. And then if we were to take I'm going to press the tab key here to hide these two components. If we were to take these faces here and these faces here and width mate that and then concentric that, now we've got this set of mates here that are related to this component. So these two components are only related to each other, but here if I shift tab to bring these other parts back, now what we could do is we could do a right mouse button copy with mates, right mouse button copy with mates, and then we could pick these two components, the washer and the rivet, and then we could say that we want to repeat the mates that are used to lock that into place, but over here with a concentric and a coincident mate. So now that's locked in. Now I just right mouse button to do it again, and now I can come down here to oops, let me try that again. I didn't have the push pin in. I wanted you to see kind of what this looks like when you rip through an entire assembly. So right mouse button, copy with mates, and this guy, and next, and then let's push pin that. So concentric to this face, coincident to this face, right mouse button, and then you come down here and you say concentric to this face, coincident to this face, which it already is, so you can just do a repeat and hit the green check mark. So when you have a lot of hardware that you have to drop in all throughout the entire assembly, that's kind of how you can make it happen. And then I guess we could even do a symmetry between some of these faces if we really wanted to go crazy with this thing. But I don't think we need to go crazy with this thing. I think this is probably a pretty good stopping point. It's 9:23. We've gone a few minutes over our typical 60 minutes together. Let's see here. Tom Smith says Tong assembly mass 1.747 pounds. How close am I? Let's find out, my man. So we go mass properties. 1.75. Wow. Pretty darn close. 1.747, 1.75. You nailed it, bro. Just working from those pictures and watching me. That's super impressive. Man. Well done, Tom. Alrighty. Let's take a look at our final answer from our poker challenge. The final answer for that one was 573 grams. 573. So GDDAM.3D. Very nicely done. 572.77. Christian Miller came in with 569.49. Very, very close. Tom Smith, 573. That is correct. That is what I came up with as well. And Cadwa Chris came up with 569.62. Also very, very close on that poker. So nicely done, everyone. And if you guys enjoyed the session tonight, be sure to give me a 1 in the chat. I very much enjoyed having all of you here with me tonight. It's wonderful to get back. I'm glad that we were able to go through and build that assembly. We kind of started out with a plan. We deviated from it a little bit, but in the end, we were able to kind of come back together, get everything together, and put together that poker. I hope that you learned some tips along the way, a little bit about using a sketch picture, a little bit about, kind of coming up with a plan in the beginning and working through it, doing a loft from a face to a face with tangency. We also talked about using a surface flatten command in lieu of sheet metal. If you can't flatten something with sheet metal, maybe you could flatten it with a surface flatten command. So lots of pretty cool lessons in this thing, but ultimately I'm just glad to be back with you guys a little bit. It's a pretty crazy world right now, and I think that it's fair to say that when I started doing this TooTallToby live stream, it was all about, community. It was all about getting together with you guys and continuing to build the community. And I just think it's so important, and it's so good to be back here with you guys and reading the chats and just kind of interacting with you again. And I think it's just one of those things that no matter what happens in the outside world, as long as we still have each other and we're all still treating each other with respect and dignity, like there's nothing that can break that. That's what it's really all about. And it's been awesome to be a part of this so far, and I'm glad to be getting back into streaming again with you guys. So thank you guys for being the best chat ever, and I'm looking forward to doing another one of these soon. I don't know when the next episode will be, but whenever it is, I'll see you then, and I hope everybody has a great night. See you, everybody.